So let us see this example number 16, where we have to find the square root of this decimal number 38.44. As I said to you, that in the case of the decimal number, only the placing of bar sign is an important role. Rest the concept is same as we used to do it in the whole number, where we have to find the square root. Now here, putting a bar sign on the every pair of digit of the number, starting from the unit place and moving to the left in the integral part has been done. That means when we are getting a whole number, always what we used to do, we start our pairing from which place? From the unit place. And we are moving to the left of the integral part. Now, but in the decimal part, the 10th place, 10th means what here, the decimal place, we'll move it from the right of the decimal part. That means here the pairing will be done from here to here, toward the right hand side. But for the integral part, that is for the whole number, the pairing will be done toward that side, that is toward my left hand side. That is, they are just opposite to each other. This is the only thing you have to remember it, that before you start the division process, in the long division process, in the case of the decimal part. Now again, as we have paired it, since we know that the 44 is one such pair and 38 in another pair, so my first pair comes out to be 38, and first of all we have to see what a square table group. The first the pair is been always selected by the square table, and we know that 6 square, which comes out to be equals to 36, so we'll place it here 6, and the quotient part also 6, subtracting, the remainder comes out to be equals to 2. Now we are annexing the next number, that is the number 44 we are bringing it out, which comes after the decimal sign. So where will be the decimal sign will get shifted toward my quotient part. So you can see here the 6 point they have written it, and 44 they have brought it down. That's a normal process what we have done in the normal division. So what happened after this one, so you can see here we have to double this number 6, which comes out to be equals to 6 plus 6, which comes out to be equals to 12, and selecting a number such that on multiplying the results comes out to be equals to, that is whatever the digit you are selecting, the same digit we have to multiply. That is 1, 2, 2 if you are writing, then you have to multiply it by the number 2. You can see the results comes out to be equals to 244. Placing it here in the quotient part also and subtracting, you will find that the square root of 38.44 equals to what? 6.2. Now again the last, this is the estimating of the square root. Now as we have explained earlier, these examples are of the perfect square. Now if sometime if appears that it's not a perfect square, we have to calculate, suppose as they have said it here, we have to calculate the square root of 200. We have to, area has been given, area of the square has been given 200, and we need to calculate mirror frame is to be performed and prepared, and I require the side of this mirror frame. Then what you are supposed to do? So in this case we have to use approximation method. So again we will use the concept of long division method. Again we will start pairing it, and definitely the remainder will be there, and we'll take the decimal part, then we'll round it off. If it is after decimal we are getting 5 or more than 5, then we'll give 1 carry forward to the next number, and if it is less than 5, then we'll keep the number as it is. So you can see here, and this as they have said it, square root of 200 is coming out to be equals to 14, so which is approximately equals to. So you calculate by this method and try to do this exercise, and if there is any problem, please do comment me in your comment box, so that we can discuss these questions once again and we can calculate the square root.